What is the indefinite integral of 3x over 7 plus 9x? How would you find this answer? For this particular problem, the best thing to do is to find the direct formula by consulting the table of integrals. So here's the formula that you need. The integral of u over a plus bu du is equal to u over b minus a over b squared natural log a plus bu plus c. That's the formula you need in order to do this. Now, by the way, for those of you who want access to the formula sheet that has these formulas, feel free to check out the links in the description section below. There's a formula sheet that you can download that has these formulas that you'll find useful, as well as other integration formulas. Now, we can't really do U-substitution on this because the degree of the numerator is the same as the degree of the denominator. So U-substitution won't work here. We can't do trig substitution or integration by parts. It just doesn't apply. So we need to use this formula. The first thing we need to do is identify the values of a, b, and u. So we can clearly see that the 7 corresponds to a. So a is equal to 7. Now 9x, that is equal to bu. So if 9x is equal to bu, what's b and what's u? Well, b is going to be the 9, u is going to be x. So this 3x doesn't equal u, just the x, which means we need to move the 3 in the front. So this becomes 3 times the integral of x over 7 plus 9x. So this part applies to this equation, which means we need to multiply this answer by the 3 that's in front of it. So let's go ahead and begin. This is going to be 3 times u over b. U is x, b is 9, minus a is 7, over b squared. B is 9, so b squared is 81. Natural log a plus bu, that's going to be the denominator, 7 plus 9x. And then plus c. So that is the answer. Now, when dealing with the table of integrals and the formulas associated with it, I recommend that you verify your answer by taking the derivative of your answer and to see if it gives you the original expression. So let's go ahead and do that. I'm going to distribute to 3 first before taking the derivative. So 3x over 9, that reduces to x over 3. And then we have minus 81 divided by 3 is 27. So this becomes 7 over 27. And then natural log. We don't need to multiply the constant c by 3 because it will still be a constant. So now let's take the derivative of everything here. The derivative of x over 3, or 1 over x, 1x over 3 is just 1/3. Now the derivative of natural log, it's going to be u prime over u. So u prime, the derivative of what's inside, is the derivative of 7 plus 9x is just 9. And then divided by u, that's the original expression of 7 plus 9x. The derivative of the constant c becomes 0. So the question is, does this expression equal what we have here? That's what we got to find out. In order to find out, we need to get common denominators. So we don't really need to change this fraction, but this one, I'm going to multiply it by 7 plus 9x and also a 9, top and bottom. So I have 1 over 3. I'm going to multiply it by 9 times 7 plus 9x. In order to maintain the value of the fraction, whatever we do to the top, we must also do to the bottom. So notice the denominators are now the same, 27 and then 7 plus 9x. So we can combine this into a single fraction. The 27, I'm just going to leave it as 3 times 9 and then 7 plus 9x. This will help in simplifying this result. So here I'm going to distribute the 9 and 7, that's 63, and then 9 times 9, 81x, and then this is 7 times 9, which is negative 63. And as you can see here, 63 and negative 63 will cancel. So we're left with 81x over 3 times 9 times 7 plus 9x. Now 81 divided by 9 is 9. So we can cross these out, and that's going to leave us a 9. And then 9 divided by 3 will give us a 3. So we'll end up with 3x over 7 plus 9x. So we started with the original problem. So that tells us that the answer that we do have, this is the correct answer. This is the indefinite integral of the original expression. Now let's try this example. Find the indefinite integral of 4 over 3x times 5 plus 2x. If you want to pause the video, feel free to do so at this time. Now we need to find the formula that corresponds to it, and here it is. The indefinite integral of 1 over u times a plus bu du is going to be 1 over a natural log u over a plus bu plus c. And I recommend checking the answer like we did before, because the fourth example will illustrate why this is important. So what's a, what's b, and what's u? So let's focus on a plus bu, which is here. So we could see this is a and this is bu. So a is 5, bu is 2x, which means we're going to make b equal to 2, u equal to x. So if this u is x, then the 3 and the 4, we got to move it to the front because it's not part of this equation. So first, let's rewrite this equation. Let's move the 4 over 3 to the front. So we're going to have a 1 on top, an x on the bottom, and then 5 plus 2x dx. So now we have it in the form that we want to have it. So now let's plug and chug. So this is going to be 4/3 times the answer that we have here. So 1 over a is 5, and then natural log, absolute value. We can't have any negative numbers inside a natural log. U is x over a plus bu. So that's a plus bu. 5 plus 2x. So that's our answer. Now all we need to do is confirm it and make sure we indeed have the right answer. So let's distribute the 4 over 3. So this becomes 4 over 15 natural log x over 5 plus 2x plus c. Okay, so we know the derivative of ln u is u prime over u. And this whole thing is u. U is x over 5 plus 2x. So we need to determine u prime, which means we need to use the quotient rule, which is vu prime minus uv prime over v squared. But because we already are dealing with u, let's use a different formula. Let's use the quotient rule in terms of f and g. So u prime is going to be gf prime minus fg prime over g squared. So g is 5 plus 2x, f prime, f is x, so f prime is 1, minus f, which is x, times g prime. The derivative of 5 plus 2x is 2. And then this is all, it's going to be all over g squared. And g squared is 5 plus 2x squared. So all of this is u prime. Now we need to divide u prime by u. And u is this again, what we have on the inside. So I need to get rid of this to make some space. So let's divide all of this by u, which is x over 5 plus 2x. And we need to keep in mind that this is all multiplied by 4 over 15. So the 4 is on this numerator, the numerator of the big fraction, and the 15 is in the denominator. Now to get rid of the smaller fractions, I'm going to multiply the top and the bottom by the denominator of the first fraction, or the fraction on top. So these will cancel. And only one of these will cancel, so I'm going to have a 5 plus 2x left over. In the numerator, I have a 5, I have a 2x, and I have a negative 2x. Here I have x and 5 plus 2x. So I'll just leave it like that. And then we have a 4 and a 15. So times 4 over 15. Two x and negative 2x will cancel. So I have a 5 times a 4. The 15, I'm going to break it into 5 and 3. And then I have an x. And then I have 5 plus 2x. So you could see the 5s will cancel. And then I'm left with 4 over 3x, 5 plus 2x. So we started with the original problem that we have. So that tells us that this answer that we have is indeed the right answer. We just confirmed it. Now, let's move on to example 3. Find the indefinite integral of 7x over the square root of 4 plus 3x. Like before, notice that the degree of the numerator and the degree of the function inside the radical is about the same. So we can't really use U-substitution. Now, if you include the square root, the degrees will be different. But still, U-substitution won't work in this example. At least the typical U-substitution that we're familiar with. So let's use the table of integrals. The formula that we need is this. The integral of u over the square root of a plus bu is this. It's 2bu minus 4a over 3b squared times the square root of a plus bu plus c. And once again, I recommend checking out that formula sheet, which will have these formulas in addition to other integration formulas that you'll find useful. So we can clearly see that a plus bu is 4 plus 3x. So a is 4, bu is 3x. So that means b is 3, u is x. So that 7 we need to move to the front. So let's rewrite this as 7 times the integral of x over the square root of 4 plus 3x. So now it's in this format. So this is going to equal 2 bu. Bu is 3x minus 4a. A is 4 over 3b squared. So b is 3. And then times the square root of a plus bu. So 4 plus 3x. So this should be our answer. But first, let's simplify our answer. So 2 times 3x is 6x, 4 times 4 is 16, 3 squared is 9 times 3, which is 27, and then we have the square root of 4 plus 3x plus c. Okay, so let's go ahead and find the derivative of this answer to confirm that it's indeed the original problem. So first, I'm going to break it up into two fractions. So we have 6x over 27 and minus 16 over 27, and all of that is times the square root of 4 plus 3x, and then plus c. So in order to differentiate this problem, we're going to have to use the product rule. So if you recall, the derivative of uv is going to be u prime v plus uv prime. So let's think of this as u and v. The derivative of u, this whole thing, is just going to be 6 over 27. This is a constant, so that's going to disappear. And then we're going to write v. V is the square root of 4 plus 3x. And then plus u. We could leave u like this. It might be better to do that. 6x minus 16 over 27. And then v prime. So v is 4 plus 3x to the 1/2. To differentiate that, we need to use the power rule. So 1/2 times 4 plus 3x, and then 1/2 minus 1, that's negative 1/2. And then the derivative of the inside, the chain rule, the derivative of 4 plus 3x is just 3. Okay, so now we just need to rearrange this to see if we can make it equal to the original expression. So this is 6 times the square root of 4 plus 3x over 27. Here we have plus, there's a 3 here, and then we have 6x minus 16. We have a 2 on the bottom, a 27 on the bottom, and this radical, I'm going to move it to the bottom since it has a negative 1/2 exponent. So now it's positive. So now we need to combine these two fractions into a single fraction. So to do that, I'm going to multiply this one. This first fraction needs a 2 and this radical. So I'm going to multiply it by 2 radical 4 plus 3x. And that, I need to rewrite it. So now that we have the same denominator, we can write this as a single fraction. So here we have 6 times 2, which is 12. Now when we multiply these two, the radical will disappear, giving us just 4 plus 3x. And then plus the stuff in the second fraction, in the numerator of the second fraction. And then we can write this over a single denominator. Twelve times 4 is 48, and then 12 times 3x is 36x. 3 times 6x is 18x, and then we have minus 16. And on the bottom we have 2 times 27 times root 4 plus 3x. And I need to correct something. I just realized a mistake I made. 3 times 16 is not 16. 3 times negative 16 is negative 48. Now, notice that we can cancel 48 and negative 48. And 36x plus 18x, that's going to be 54x. Now, notice that the 54x, well, 54 will cancel. And I'm left with x over the square root of 4 plus 3x. Now, one thing I forgot to do, the reason why this doesn't appear the same, it's missing a 7, which tells me I forgot to multiply this by 7, which I clearly did. So, had I multiplied this by 7, we would have a 7x here. So I'm going to put that 7 in the final answer. And I'm going to take out a 2 from 6x and 16x. So we confirm we have the right answer. We just need to multiply our final answer by 7. So I'm going to have a 7. I'm going to take out a 2. 6x divided by 2 is 3x. 16 divided by 2 is 8. So our final answer, we can write it as 14 times 3x minus 8 over 27 times the square root of 4 plus 3x plus c. You know, that's another reason why it's good to check your answer. It'll remind you if you forgot to multiply by a constant, which I did. But now that's been corrected, so this is the final answer. And of course, you could differentiate it following the same techniques that we did to get this answer. Now, let's try this one. Find the indefinite integral of 1 divided by 4x squared minus 25. So the formula that we need for this one is 1 over a squared minus u squared du. If you want to try U-Substitution or Trig Substitution, feel free. But I'm going to use the table of integrals. So don't forget to download that formula sheet if you want these formulas. So this is going to be 1 over 2a times the natural log of u minus a over u plus a. With this formula, I definitely recommend checking your work, and you'll see why. So we can clearly see that, actually I wrote this the wrong way. This is 1 over u squared minus a squared for this formula. 1 over a squared minus u squared is a different formula. So u squared is going to be 4x squared. A squared is going to be 25. So let's write that. If u squared is 4x squared, that means u is 2x. If a squared is 25, a, the square root of 25, is going to be 5. So using the formula, it's going to be 1 over 2a. That's 2 times 5, which is 10, times the natural log of u minus a. U is 2x, a is 5, and then u plus a. So 2x plus 5, and then plus c. So with the formula, it's very easy to get the answer, but checking your work, that takes time. Okay, so let's go ahead and differentiate natural log. So u prime over u. U is going to be 2x minus 5 over 2x plus 5. U prime, we need to use the quotient rule. So let's say the top is f, the bottom function is g. So it's g f prime minus f g prime over g squared. So g is 2x plus 5 times f prime. The derivative of 2x minus 5 is 2, minus f being 2x minus 5. G prime, the derivative of 2x plus 5 is 2, all divided by g squared, which is 2x plus 5. And now we need to divide all of this. So I'm going to color code the main fraction. All of that is going to be over u, which is that. So u prime, so this part is u prime, and then divided by u, which is what we have here. And let's not forget the constant that's in the front, so times 1 and times 10 on the bottom. Now let's simplify. So I'm going to multiply the top and the bottom by 2x plus 5 squared. So these will cancel. Here I'm going to have 2x times 2, which is 4x. 5 times 2 is 10. 2 times 2x is 4x, but don't forget the negative sign. So that's negative 4x. 2 times negative 5 is negative 10 plus the negative side. So that's going to be positive 10. These will cancel. So I'm going to have a 2x plus 5 left over because this one is squared, this one is not. So on the bottom I have 2x minus 5 times 2x plus 5. And I have the 1 over 10. So I'm going to multiply the top part by 1 and the bottom by 10. So 4x and negative 4x will cancel. 10 plus 10 adds up to 20. And on the bottom, we could FOIL 2x times 2x, that's 4x squared. Now 2x times 5 is 10x. Negative 5 times 2x is negative 10x. They will cancel. And then negative 5 times negative 5 is negative 25. 20 divided by 10 is 2. So as we can see, this integration formula, it didn't give us the exact answer, but it got us very close to it. Our answer is basically twice what our original answer is. So to get our answer, we just basically need to divide this by 2. We need to change 10 to 20. But you might be wondering why. Well, recall that u was equal to 2x. U prime is going to be 2. So in order to make this equation work, we need to divide this by u prime, even though it wasn't mentioned in the formula. By the way, this will only work if u prime is a constant, like 2, negative 3, 5. If it's 4x or 7x plus 2, it's not going to work. So if you're going to divide it by u prime, make sure that u prime is a constant, which means u has to be a linear function. If u squared was like x to the fourth, u would be like x squared, and u prime will be something with an x. It won't work in that case. So I'm going to make this 1 over 20 instead of 1 over 10. By doing that, I'm going to get the right answer. So this equation wasn't perfect, but it was good enough that it can help us to, it can lead us to the right answer. We just had to check our work and then make the adjustments. Let's try another one like this. Let's say we have 1 over, actually let's make this 9x squared minus 16. Feel free to try that problem. So let's write the formula. 1 over u squared minus a squared du. You can find it in the formula sheet below. Equals 1 over 2a ln u minus a over u plus a. So u squared is going to be 9x squared. U is going to be 3x. A squared will be 16. A is going to be 4. So based on the formula, it's 1 over 2a, the formula that I found in the table of integrals. So it's 1 over 8, natural log, u minus a. So u is going to be 3x, a is 4, u plus a is 3x plus 4, and then plus c. So now let's confirm it. I'm just double checking my work, making sure that I plugged in everything correctly. Alright, let's find the derivative of this using the quotient rule. So it's going to be g is 3x plus 4, times f prime, which is 3, minus f, that's 3x minus 4, times g prime, which is 3, over g squared. And then, so all of that is u prime, and then divided by u, which is basically what we have inside. And then times 1 over 8. Now let's multiply the top and bottom by 3x plus 4 squared, just like we did before. So these will cancel, and we'll have a 3x plus 4 left over. So 3x times 3, that's going to be 9x. 4 times 3 is 12. This is 9x, but with the negative sign in front, that's negative 9x. This is negative 12 times negative 1. That's going to be positive 12. On the bottom, we have a 3x minus 4 and a 3x plus 4. And then times 1 over 8, the constant in front. So we could cancel 9x and negative 9x. And then we have 12 plus 12, which is 24. And then 3x times 3x is 9x squared. 3x times 4 is 12x. Negative 4 times 3x is negative 12x. So they will cancel. And then negative 4 times 4 is negative 16. And then we have times 1 over 8. 24 divided by 8 is 3. Notice that this is 3 times the original answer. And keep in mind, u was 3x, so u prime is 3. To make this work, we need to divide this answer by 3. So dividing it by 3 is the same as multiplying the denominator by 3. So 8 times 3 is 24. So by doing that, we now have the correct answer. So with that formula, you just have to divide by u prime if u prime is a constant. If u prime has a variable, it won't work. So that's it for this video. So whenever you're using a table of integrals, if you have the time for it, I recommend checking your work.